Question 9 is actually pretty straightforward. It's just asking you, how can you use two different colors of counters to create a scenario in which a probability of 4 out of 17 could be tested? If we were testing a probability of 1 out of 6, or 2 out of 6, or 3 out of 6, we could just roll a dice. If we were testing probability for 1 out of 2, we could flip a coin. If we were testing probability for 1 out of 4, or 3 out of 4, you could just design a little spinner like this and have 4 different colors and test it that way. How can you use two different types of counters to create a simulation for 4 out of 17? Well, I would need two different colors of counters, one that is a success, which is the 4, and other colors, so let's say that's red, and another color that is for the non-successes or the non-favorables. So in this case, it's not 17, it's 13. So that's why this simulation question works well with our odds questions, because it's asking you to create an experiment that simulates a probability of 4 out of 17. Remember, our probability is 4 out of 17. That's favorable over total. But in terms of what we'd actually have to put in the bag in order to pull out 4 out of 17, now we're looking at odds, which is 4 to 13. So the answer to the question is, you would put 4 red and 13 green in a bag, and you would pull them out, and that would be how you simulate. Question 10 asks you to describe a simulation you could use to estimate having exactly 2 boys in a family of 3 children. So I'm going to run through kind of the order. First thing we have to do is find an experiment that's going to match the probability of having boys and girls. And so that's going to be flip a coin, because that is 50% probability, and that's what we're looking for. So the second thing we have to do is to define which is which. So we have 2 outcomes, heads and tails. What are we going to define them as? Heads will be boy in this case. Tails will be girl. It wouldn't make a difference if you did it the other way around. So step 3, now we got to decide how many times are we flipping. So if I want to simulate having exactly 2 boys in a family of 3, I have to test families of 3. So that means I would have to flip 3 times for one family. 3 times per family. And I'm going to want to test a lot of families. In this case, I'll do 5, just for argument's sake, but you would describe doing 10 or 15 or 20. So I'm going to do it like that. So then I would flip coins. And let's say I had heads, tails, tails, heads, and then tails, heads, tails. Let's say I had that. That would be an example of a very small simulation. I flipped 15 coins, and then I put them in the groups of 3 to represent families of 3, and then I counted which ones had 2 boys. This one does, and this one does, and that's it. So I would then count the number of favorable. So that would be kind of step 4. It would be count favorable outcomes. In this case, there's 2. And then 5 would be calculate probability. All I need to do there is put 2 over the total number of outcomes. How many families did I do? 5. So my probability would be 2 out of 5. Again, this is just a made-up experiment. When you're writing your simulation on your test, it's going to look sort of like this. You're going to pick stage 1, which is an experiment that matches the probability. You're going to define what everything means. Then you're going to just explain to me how many times you would flip it. If it was me in real life, I'd probably flip it 300 times. 3 for family for 100 families. I'm not going to ask you to do that on the test. I'm going to ask you to just explain it on the test. So just say, I would flip 300 times and put them in groups of 3. Then you would just tell me. Then I would count the number of groups of 3 that had 2 heads. Then I would put that number over 100, and that would be my probability, and you'd be done. So the second part of this question is, what's the probability the oldest child's a boy? Well, we actually have to do the entire experiment if we're going to figure that out. So it says, what's the probability? That's asking us for theoretical. So let's do the 3 coin flips. Heads and tails. Heads and tails. Sorry, that was a bit messy. Heads and tails. Heads and tails. Heads and tails. Heads and tails. Now, I'm going to label this just like I did back in question 4. So this is 3 boys, 2 boys, 2 boys, and just to explain why, 1, 2, 3, 3 heads, that's 3 boys. 1, 2, not a boy, that's 2. 1, not, yes, that's 2 again. 1, not, that's 1. So boy, boy, that's 2. 1, 1, 0. So that's just the number of boys. Now how many have a 2? That one, that's 1. Oops, sorry. Right, like that, that's 2. And that's going to be 3. This one here. So 3 out of 1, 2, 3, 4, 5, 6, 7, 8. 3 out of 8 is the probability of having 2 boys. Now, what is the probability the oldest child will be a boy? That question is a little bit weird because it depends on what you're asking. Is it, what's the probability the oldest child will be a boy in a family that has 2 boys? Or what's the probability that just in general the oldest child will be a boy? If you're answering the first one, we need to look at all of the outcomes. So we had head, 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 tail, head, tail, head, head, tail, tail, and then we had tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So let's look at this. This one has 2 boys, this one has 2 boys, and this one has 2 boys. How many in these families was the last child a boy? Well, there is 1 and 2, so that would be, sorry, let me highlight that. 1 and 2, this one does not. So some people might tell you it's 2 out of 8 chance that you will have 2 boys and the oldest will be boy. And that makes sense. The other thing they might have meant is just what is the probability that the last child's a boy? In that case, we'd look at all 8. So it depends on how you interpreted that last question. I think it was intended to be what is the probability the oldest child will be a boy in these families of 3 that have 2 boys. So there you have a 2 out of 8 chance of having 2 boys, and one of your 2 boys will be the oldest child. The other thing they might have meant is just what's the probability of child number 3 being a boy in any 3-child family? Well, that's 1, 2, 3, 4, half. That one's kind of more common sense, which is why I don't think that's what the question is actually intended. So keep that in mind. If you're going to be asked a question like this on the quiz, it's going to be a lot clearer, and it's going to explicitly ask you, what's the probability of having something like 2 boys, and in particular, what's the probability of having 2 boys and the oldest be a boy? Then you would find this type of all of the outcomes and which families meet the criteria and how many of them have the oldest kid being a boy.